Okay, we're going to talk about simplifying radicals. What a radical is anything with a root symbol, like a square root, or it could be a cube root, and so on. So a radical is simply the root. And the way we're going to simplify this is we're going to find factors when it comes to simplifying a number root, and then we'll learn how to simplify variables as well. And also what we'll talk about is they don't allow radicals in the denominator of a fraction. And one method, this word here, conjugate, is a method for eliminating radicals from the denominator. Okay, as it says up here, they call it simplifying radicals. And even though the simplified form doesn't look any simpler than what we started with, that is what they call simplifying radicals. A little bit of refresher. When you multiply two radicals, for example, the square root of 3 times the square root of 5 is the square root of 15. Square root of 5 times square root of 10 is the square root of 50, and so on. And 2 squared is equal to 4, so the square root of 4 is 2. 3 squared is equal to 9, therefore the square root of 9 is 3. And if we want to simplify something like the square root of 18, what we want is a factor of 18 that has a whole number square root, like these numbers here. And there are larger ones, like the square root of 25 is 5, and so on. But if we look at 18, we see that, yeah, 9 is a factor of 18, so we could break this into the square root of 9 times the square root of 2. The square root of 9 is 3, so 3 times the square root of 2 is the simplified form of the square root of 18. Essentially, we're getting as much out from under the radical as we can and into the integer form. Well, let's look at a couple more examples. The square root of 72, perhaps you would first think of the square root of 36 times the square root of 2, and you'd be choosing 36 because the square root of 36 is equal to 6 times the square root of 2, and we can't simplify 2 any further and we would be done. On the other hand, perhaps you might have thought of, well, how about the square root of 9 times the square root of 8, because the square root of 9 is a whole number, 3. So then you'd have 3 times the square root of 8. However, you have to look at this 8 and see if you can simplify this further, and 4 is a factor of 8, so we could break this into 3 times the square root of 4 times the square root of 2, which is equal to 3 times 2 times the square root of 2, which is equal to 6 times the square root of 2. So what you notice is no matter which way you did it, you still come up with the most simplified form, 6 times the square root of 2. Okay, let's look at the square root of 48 now. Well, again, perhaps you thought of 16 times 3. In which case you would have 4 times the square root of 3. And even if you didn't think of the largest factor, you might have thought of the square root of 4 times the square root of 12, which would give you 2 times the square root of 12. But again, this 12 has a factor of 4, so we could break that into 2 times the square root of 4 times the square root of 3, which is equal to 2 times 2 times the square root of 3, which is 4 times the square root of 3. Again, we have the same final simplified form. On the next section, we're going to look at how to simplify variables. Again, moving as much out from underneath the radical and outside the radical.